So this is the number 26. So we have x, y, z are real numbers, and then the equations are given. And then we want to find the squares, some of those squares, okay? And that's the common fraction. It's like we have like x, y, and as a product, and then there is some going on, and then there is some going on. But when you look at the equations, there is a actually nice symmetry going on, which means like I have like x is right here, which is like 2 times as a product, and then y is here, and then there is another y right here. So that's just 2 times product. And then if you look at the sum, that is the same as well. So in those kind of cases, like we do want to kind of see if there is like some sort of easy way to manipulate the given expression. Otherwise, like if you want to like expand these guys, it is going to be way messy, which is what we don't want to try. So that's why I'll just try to do a bit substitution to make this a bit nice looking. So what I'm gonna try like since the equation, all three equation has x, y, z twice somehow in every single equation, I will combine x by y, z. So if I just do that in the first equation, let's say x times y plus z, I'm gonna say this product is equal to, let's say a. And the remaining ones, so we have y, and then x and z, x plus z. And then I'm going to call this as b. So again, we have x, y, z. We have x, y, z in the equation. And if I look at this second equation, so we have x, and then I took the y, z with x already. So that is z left. So z times x plus y. And I'm going to call this is going to be equal to c. Okay, so now if I want to like plug this into the given original equation, I will get a bit nicer expression. The first one was like if I take the x, which is x right here, y plus z with these, that was a. And then the remaining one, so y and x plus z, y and x plus z is just b. So the first equation became now a plus a times b equals 165. And I can just find the prime factorization, like it's divisible by 5, even 15. I mean, yeah, actually it's divisible by 15. If I divide by 11, so that should be 1, and then that's 55, so 1, 5. Okay, and then the second equation now we have is x right here. We took x and y plus c, which is this guy, that is equal to a. And then remaining one is the z and x plus y, zx plus y is c, so that is equal to 88. So I'm going to write as 11 times 8 or 2 cubed. And the last one, we have y and zx. So y and zx is b, so that should be b, and then times c. And this is 120. So 120 is like, I can divide by 4, that's 30. So divide by 2 again, that's 8. So 8 times 15. So I'm just going to leave these because I like to get a perfect square, because as you see on the left side, we have the ABCs like 2 times. So I can just go ahead and multiply these. If I multiply these equations, because when you have symmetric equation, it's better to multiply or divide or add, sometimes subtract. But if I multiply these, you will get the square of each variable, and then I will just take the square root of both sides. So that will be 11 squared will be just 11, and then 15 squared will be just 15, and then 8 squared will be just 8, okay? So now we have ABC. Since we know the AB, so we can just find each variable as well. So from there, if I divide this equation by BC, 8 times 15, so then you will get A to be 11, right? And then if I like find the B and C as well. To find B, I'm going to divide this equation by AC, which is 8 by 11. 8 times 11, so that will be 15 for B. And then if I divide by AB, so 11 and 15, so you will get A for C. Okay, this is promising because we were able to at least get some of the expression that we did substitution. So now let's see what we can do after, right? And what we had was like the A, B, and C, but how this is going to be useful. And also like if I kind of expand these, that will be x, y, x, z, y, x, and y, z, z, x, and y, z, which means like every pair product is actually twice on the left side. If I add these, so you will get 2 times x, y, 2 times x, z, and then 2 times like YZ. And then this is equal to sum of ABCs. We know the ABCs are here. So that should be 26, 34. And then the XY, XZ, and YZ add up to 17. Okay, so we are getting something, but now what, right? So what we want is the sum of the squares of those X and YZ. So like we can maybe like look at the equation. We know the A was 11, B was 15, and then C was 8. And if I expand this, that's XY plus XZ. So XY plus XZ, it's 11. So then YZ should be from here. So YZ is going to be 17 minus 11, which is going to be just 6, right? And if I kind of do the same thing with the other ones, like if I plug this guy, so XY and YZ, so the XY and YZ add up to 15. So then XZ should be just 2, right? And for the last one is the XY. So if I plug this guy, which is XZ and YZ, so the YZ and XZ add up to 8. If I subtract that, so you will get just 9 for this guy. And as a final step, we want to find the sum of the squares of the X, Y, Z, right? So now this product has X and Y and Z 2 times. If I multiply these equation, so you will get X squared, Y squared, and Z squared equals, like I have 9 is a perfect square, so that's 12, which is not perfect square. Maybe we should just leave it as that. So 9 times, this is 2 times 3 times 2, which I can write 4 times, I guess, 3. So the goal is just to find the X squared and Y squared and Z squared, right? So if I divide this equation by like the square of these guys, let's say if you want to divide by YZ squared, so you will get the X squared, so which is going to be X squared equals 9 times 4 times 3 over YZ squared. YZ is 6, so I can just say 6 times 6. So that will give us like 12, so that should be 2. That's 18, that's 3. So we have, that is 3 for X squared, right? So let's keep this in mind. Okay, and then if I do the same thing with the other guys, so I will get the Y squared. To get the Y squared, I'm going to divide like this equation by XZ squared, which is equal to 4. So that will be 9 times 4 times 3 over 4, which is 27. So you got 27 for this guy. And the last one is the Z squared. To get the Z squared, I'm going to divide by square of the 9. So you should get 9 times 4 times 3 over 9 squared. So these will cancel. So you get 3. So 4 over 3. Okay. So then we have 4 over 3. So that's 30, right? Plus 4 thirds. So if I add this, that will be 90 plus 4, so which is 94 over 3. So it was a bit challenging, to be honest, especially when I compared this one with the remaining questions. So this was a bit more algebraic manipulation, but still, this is not too bad, I guess. And then there are some other ways that you can try actually. Maybe we can find another way that is maybe better than this one, but at least this is actually working, okay? So let's take a look at the next question. So here's now 27. So we have a geometry problem. So in this given figure, the circle is O has an area of 625, which is like radius 25 of this largest circle. And then CD is 16, AB is 30, and the area of the shaded region. Like it says the area of the circle that intersect with the point ABC. Look at the ABC. This is a point on the shaded circle. That's also, which is kind of remind me like the area formula for circumscribed circle, which is something like this. Area equals A times B times C over 4 times radius of the circumscribed circle. If you don't know how to get this one, I highly recommend you to take a look at the video that I actually made a proof about it. I will attach this into the this video as well, so you can review that. Because if you kind of don't use this much, so you are gonna easily forget about this one. but this is also a useful one. So maybe that might be what I'm gonna try using, right? So like what we have now, like the radius of this large circle is just 25 because the area is 625. So which is why this is 25 for this guy. And then that is CO will be 9. And what I like to find is the radius of the circle. So if I want to find the radius of the circle, I need 3 sides. That includes the triangle ABC, like size of that one. So which is why I do need to know the BC as well. I know the AC, I know AB. If I know this guy, then I can actually find the radius if I find the area, because area is also easier to find when you have 3 sides. So now let's look at what we can do to find this BC. So the first thing we can try, maybe connect this D to B, because this is a diameter. When you have a angle on that circumference, circumscribed circle, then the angle right here is 90 degrees. That has even a name, which is called Taylor's theorem, right? So you can say easily the angle right here is 90 degrees. And this is 30 and the hypotenuse is 50, which is 3, 4, 5 triangle. So BD has to be just 40 if you use like a triple. And now what? Like we want to find the BC, but we don't know that BC yet. What we can do, maybe we can drop the altitude from B to AD, because if I find the area of ABD in 2 different ways, so I can actually find the height easily. So if I name this as H, the area of that ABD, right? So can be written as 30 times 40, which is the leg and the leg divided by 2. Or we can just say height times AD divided by 2 as well. So the H times like 50 over 2. And then you can even cancel these. Zeros will be gone. And then you can divide by 5. So that should be 24. So the height of that triangle is just 24. So which is nice number as well. So we have 24. The hypotenuse is 30. You know, this is like 5 times 6. This is 4 times 6. So that is 3, 4, 5, which means this is 18. So if I subtract 18 from that, so the remaining part should be just 7 for this piece. And then I have 7 plus 9, which is 16. So, and then this leg is 24. So I have a triangle where the legs are 16 and 24. So let's kind of take a look at that. We may use the Pythagorean, but I'm going to kind of cheat a bit. So like we have, this is 16 and this is 24. You can just read the like Pythagorean immediately, but what I'm going to do, this is going to be like 2 times 8. And then this is going to be 3 times 8. So I'll take the 2 and 3, and then that's 2 squared, and 3 squared, 9 plus 4 is 13. So that should be root 13 if this was 2 and 3, but now it's 8 times. So I can just multiply by 8. So that means the BC should be 8 root 3. Okay, now we have every size, even the area of that triangle, because we know the height. So then the area of the ABC is equal to height is 24, and then base is 25 plus 9, which is 34, and this is divided by 2. Equals A, I can just take 34, and I should take this one as A, but let's keep that order. So the A is the side that is opposite angle A, which is BC, which is we know 8 root 13. And then we know B is the AC, which is 34. And then C is just 30. And then divided by 4 times the radius of the circle. So like we can cancel these guys easily. And then I can divide by this. That should be 12. And then I can divide this by 3, which is 10. Divide by 3, which is 4. Divide by 4, divide by 4, that's 2. And then these even cancel. So the 2 are, actually we can cancel these as well. So 5 times root 13 divided by R equals 1. So which means R is equal to 5 times root 13. So you can do this slightly differently. I just did that way and just simplify basically. And now we want to find the area of that triangle because that was the question. So the pi times the radius squared. So that's 25 times 13. So 425 is 100. So 12 will be 300, but there is one more. So 325 basically pi. Okay, so I hope that wasn't too bad. So we have 325 pi for this guy. So you can try this slightly differently. Even you may use the power of points, but I think this is good as well. Okay, so let's look at the next one. Number 28. So how many positive integer factor does this number have? So we have a lot of like factorial, which is like why we kind of need to get rid of these if possible and see if we can get some perfect square inside, because otherwise there is no way to get the perfect square divisor, you know? So then the smaller of these is 2019. So which is why I'm gonna write 2023 factorial in terms of the smaller one, 2023 times 2022 times 2021 times 2020 times 2019 factorial plus 2019 factorial, and this is all divided by 2019 factorial. So like I can just take the square root, but I'm gonna put it later. So if I put the 2019 factorial as a common factor in the numerator, so then 2019 factorial and 2019 factorial will be canceled. So you will be just left with 2023 times 2022, 2021, 2020 plus 1. So now we want to take the square root. That's because whatever we have right here, this fraction just became this number, right? And now we are going to take the square root. So like when you have big numbers like this, we try to use like some sort of substitution, especially choosing the average of those numbers. But since we have 4 numbers, there is no really right in the middle. So I can just try to choose the substitution as the number in between these two, which is going to be 22.5, or I can just write as 43 over 2, okay? So if this is my x, which is just 0.5 bigger than this, 0.5 smaller than, 0.5 smaller than this, 0.5 bigger than this, and then 1.5 smaller than this, and the same as like bigger than this. So then this number would be just the x plus 3 over 2. And then this number is x plus 1 over 2. And the next number is x minus 1 over 2. And the last is x minus 3 over 2. And there is a plus 1. So let's not forget about that. And that is on the radical. And then there is a negative 1 after. Okay. So if I multiply these two, which is going to give us x squared minus 1 over 4. And if I multiply this by this, you will get x squared minus 9 over 4, which is also another different set of square. And then that is a bit better than the previous expression. But now we don't want to expand this because it doesn't look like fun, because we're going to get x to the 4th power. So we don't want to take the 4th power of this guy. But if you look at these guys, you know, at the beginning, we kind of took the average of these 4 numbers, or just the middle number, as our substitution. Maybe we can kind of think about the similar idea. So 1/4 and 9/4 add up to 10/4, or negative 10/4 if you consider the sign. So the half is like 5 over 2. Maybe we can write these guys as this. I can just do a bit like clear manipulation as well. Since we know we kind of use the average of these 4 numbers to choose this number. So 1/4 and 9/4 is just add up to 10/4, which is like half face 5/4, or negative 5/4 if you consider the sign. So we can just write this as negative like x squared minus 5 over 4 to get negative 4, so 1/4, so you will get plus 1. So this guy is the same as this one. And the second one is x squared minus 5 over 4 and minus 1. And then there is a plus 1, right? and -1. So like now we have the another difference of squares. So this guy, if we consider as a plus 1 and a minus 1, so that will be x squared minus 5 over 4 squared minus 1. And then there is a plus 1, so those will cancel. That's why we actually need to have that 1 and then -1. So these guys will cancel, which is nicer. Take the square root, so we are going to get now x squared minus 5 over 4 and -1. And this is equal to x squared minus 9 over like 4. So this is also nicer because this is factorable as x minus 3 over 2 and x plus 3 over 2. So the x was this number, or like 22 minus 0.5. So if I like subtract 3/2 from this guy, so 43 minus 3, which is 40, divided by 2, this guy would be just 20. And then if you add 3, that will be 46, divided by 2, that will be 23. So this is really nice because if you couldn't really find this approach, you could have just guessed that, because if you look at the numbers, they are too close to each other. So maybe product of these four numbers is the same as product of the largest and smallest. And then maybe the product is equal to these two, which you could just guess if you couldn't come up with anything. So even though, it's a guess, that is actually the case. So you could just get the answer anyway. Okay. Now we got the product to be these two numbers, right, in our final answer. So like what we want to do now, we want to kind of find the number of divisors, right? So then 2020, if you kind of find the prime factorization of this, that is divisible by like 4, or we can just say 202 times 10, and then that's 2 times 101, and then 2 times 101 times 2 times 5, which is 2 squared times 5 times 101. And then 2023, so if you kind of remember the prime factorization, you can just get immediately. If you don't, so you can just try prime numbers. If you divide this by 7, so you will get like, I guess 289. So divide by 7, so that should be 2 times, that's 14. So that is 62. So that's gonna be 8 times 56. So that's 63, which is 9, which is good. So that is actually 17 squared. And when you look at these numbers, they are all different prime numbers. We are looking for the number of integer factors. So if you just multiply the power after adding 1, so we would be done. Okay, so that should be 3 times 2 times 2 times 2 times 3. So that is 6, 12, 24, 72. Okay, so I hope that was clear. So this was also another nice substitution problem. So we got the answer as 72. Okay, I'll see you in the next video.